Hi everyone, today we are going to go over the study guide for 11.1 to 11.4. Remote learners, please remember if you are taking your quiz at home, you're expected to take it during your scheduled geometry period. All right, number 1. For part A, we want to find the measure of arc ACB. So that would be ACB, this arc right here. Well, we know an entire circle is 360 degrees. We notice that this sector here has a degree of 60. So to figure out everything else, we're just going to do 360 minus 60. And that means that arc ACB would be 300 degrees. Next, let's find the measure of arc AB. Well, we already found that. If the central angle here is 60, that means that AB is also 60. Part C, find the circumference of the circle. Well, first we need to know the circumference equation. And to find the circumference of a circle, it's 2 times pi times r, where r is the radius. So if you look at the circle here, we notice that our radius is 12. So to find the circumference, I'm just going to plug in 2 times pi. Make sure you use the pi button on your calculator, times 12. And when you plug that into your calculator, we get approximately 75.4 centimeters. Next, we want to find the length of arc AB. The equation for arc length is theta divided by 360 times 2 times pi times r. So if we look at our picture, we notice that the degree measure is 60, so that's our theta. So 60, divide that by 360 times 2 times pi times our radius, which it's still 12. And I would practice plugging this into your calculator right now. And when you do so, you should get 12.57 centimeters. Question number 2. For part A, we want to find the area of the circle. Well, we know that the equation for area of a circle is pi r squared, where r is just the radius. So let's plug in what we know. We notice that the radius is 22. So pi times 22 squared, and when we plug that into our calculator, we get 1,520.5 centimeters squared. Next, we want to find the area of the shaded sector, everything that's in green. So the area of a sector, the equation is theta divided by 360 times pi r squared. So we want to focus on this angle measure right here, theta. Well, we don't know what theta is. What we do know is that this degree measure is 120. So if I take 360 and subtract 120, I would then find theta here. And when I plug that into my calculator, we get 240. All right, so now that we have theta, I know that this is going to be 240 divided by 360 times pi times r squared, which r is still 22. And if we plug this into our calculator, we get 1,013.69 centimeters squared. In part C, we want to find the length of arc CD. So since it is just 2 letters, we know that we're talking about this arc right here, this minor arc. Once again, the equation for arc length is theta divided by 360 times 2 pi r. So since we're talking about this arc, our theta this time is 120. Divide that by 360 times 2 times pi times 22. And when we plug this into our calculator, we get 46.08 centimeters. I know for all these answers, I kind of went between 1 decimal place and 2 decimal places. On the quiz, I'll tell you exactly how many decimal places to round to. For question number 3, we want to find the area of the shaded region, and we know that the edges of a square. All right, so we first need to figure out what is the area of the entire figure, the large figure. And if we look closely, we see that the large figure would be this square. Well, we don't know the sides of the square. There's no information here. But what we do know is that the radius of this circle is 3. If the radius is 3, that means that the diameter would be 6. So if the diameter of the circle is 6, that means that this side of the square would be 6, and this side of the square would be 6. So what would the area of the square be? Well, it'd be 6 times 6, which is 36. So area of our square is 6 times 6, which is 36. Now we need to figure out what is the area of this circle. So area of the circle. We know the equation for the area of the circle is pi r squared. So pi, our radius we know is 3. And we're going to square that. And I'm just going to keep this as 9 pi for right now because I want exact answers. I don't want to round until the very end. So now if I just want to figure out what is this area, I'm going to take the area of my square, which is 36, and I'm going to subtract the area of my circle, 9 pi. When I plug that into my calculator, I get 7.73 inches squared. Question number 4, we want to find the diameter and the radius of a circle with a circumference of 500 feet. All right, so there's 2 equations for circumference. The first one is circumference is equal to pi times the diameter. Well, if we know that the circumference is 500, and we know that would be equal to pi times the diameter, I can then find the diameter by dividing pi on each side. So that means that 500 divided by pi, if you plug that in your calculator, we get approximately 159.2. That would be our diameter. Well, if the diameter is 159.2 and we're trying to find the radius, we know that the radius is equal to the diameter divided by 2. It's half the length of the diameter. So if we plug 59.2 into our calculator, divide that by 2, we would get 79.6 for our radius. Question number 5, we want to find both the diameter and the radius of a circle that has an area of 10,000 inches squared. So we know that the area formula for a circle is pi r squared, and so we're going to have to find the radius first. All right, so if area is equal to 10,000 is equal to pi r squared, the first thing I want to do is divide by pi on each side, and that will give me approximately 3,183.0987, but that's only equal to r squared, and I'm trying to find the radius. So to find the radius, I need to do the square root of each side, and that gives me approximately 56.42 is equal to our radius. Now, if I want to find the diameter, I know that the diameter is 2 times the radius. So I need to do 2 times 56.42, and this will give me approximately 112.84 inches. Question number 6, find the radius of the circle. All right, if I look at my circle, what they give me is that I know that this arc length is 13 and my angle measure is 76 degrees, which means I'm going to need to use my arc length equation. So let's plug in what we know. Theta is 76. So 76, divide that by 360 times 2 pi, and we don't know what r is, but what we do know is that our arc length is 13. So we want to get r by itself, and what we do know is that this right here is a number. All right, so we can either plug this in our calculator and round, but to be the most accurate for this, and since this is a Polaris quiz, we got to be careful where we round because it might mark our answers off if we're a little off with our rounding. We know that if we're multiplying r by all of this inside the box, that means when I'm trying to get rid of multiplication, I'm going to divide by everything that's in that box. So if I take 13, I'm going to divide it by, and then in parentheses, I'm going to have another parenthesis because I need to do 76 divided by 360 first, times 2 pi, close parentheses. If you plug this just like this in your calculator, you will end up getting that r is equal to 9.8 inches. And so that is our radius. Question number 7. The area inside a circular track is 120,000 feet squared. If you walk the whole way around it, how far would you walk? So if we're walking around the edge of a circle, that's looking for the circumference. And we know circumference is equal to 2 pi r. Well, in our problem, we don't know what the radius is. What we do know is the area of the circle. So area of a circle is equal to pi times r squared. So if we find the radius for using our area, we can then find the circumference. All right, so let's plug what we know. We know that the area is 120,000 is equal to pi times r squared. All right, so I want to get r by itself, which means I need to divide by pi on each side. And when I do so, I get that r squared is equal to 38,197.1863. But I don't care about r squared, I care about r. So I need to do the square root of each side, and I end up getting that r is approximately 195.44. But we're not done because the question didn't ask what is the radius, it asked what is the circumference. So now I know that circumference is equal to 2 times pi times our radius, which we said our radius was 195.44, and if we plug this into our calculator, we get 1,227.99 feet. Number 8, find the area of this field. How much would it cost to seed if the seeding costs are 60 cents per square yard? All right, so there's two shapes that make up this field. One is this rectangle. And we can find the area of this rectangle by multiplying the length and width. So 35 yards times 100 yards, that would be 3,500. Next, we notice that we have two semicircles. We have one here and one here. If you combine two semicircles together, we would get a circle. So we need to figure out what is the area of the circle. And we know area of the circle is pi r squared. Well, we don't know what the radius is, but we notice that the diameter is 35. So what's half of 35? That would be 17.5. So that means that our radius is 17.5. So pi times 17.5. I'm going to square that. That means that that area is 962.11. So here are our two areas. So to find the total area, I need to add those up. And we end up getting 4,462.11. So this is our total area. So this would be yard squared. And now the second part of this question said that each yard, or per yard, square yard, it's 60 cents. So to figure out the total cost of seeding the field, we would just take our area and multiply it by 0.6. So 4,462.11. I'm going to multiply that by 0.60, and that means that it's going to cost $2,677.27. Question number 9, we want to find the area of the following regular polygons. So let's remember the formula for finding the area of a regular polygon. Its area is equal to, we want to find the apothem, multiply that by the perimeter, and divide that number by 2. For part A, we know what our apothem is. Our apothem is already shown here. It is 9.2. However, I do not know what one side of my polygon is to find the perimeter. What I do know is that this length right here is 10, and that means I have a right triangle. If I know two sides of the right triangle, I can figure out my third side by using the Pythagorean theorem, which means that 9.2 squared plus x squared is equal to 10 squared. I won't go through this, but when you solve for x, we end up getting that x is equal to 3.9. So if this little part is equal to 3.9, it means that that entire length is double that. So this would be 7.8. So then to find the perimeter, I'm just going to do 7.8 times the number of sides, and we have 1, 2, 3, 4, 5, 6, 7, 8. Multiply that by 8, and we end up getting that the perimeter is 62.4. So now I have everything to find my area. So area is equal to the apothem, which we know is 9.2. Multiply that by the perimeter, which is 62.4, and divide that entire number by 2, and we get that the area then is 287.04 feet squared. For part B, this time I know this length, so I can figure out my perimeter, and my perimeter is equal to 17.6 times 1, 2, 3, 4, 5, and we end up getting that that is 88. But what I don't know is what my apothem is. So I need to figure out that side, or that length, and once again I have a 90-degree angle. If this is 17.6, that means that this little guy here would be half of that, which is 8.8. So once again, I have a right triangle. I know 2 of the 3 sides. So to solve for x, I need to use the Pythagorean theorem. So I'll have x squared plus 8.8 squared is equal to 15 squared. And when we solve for x, we get that x is 12.15. So now that I have the apothem, I have my perimeter, I can now find for the area of this polygon. And area is equal to 12.15 times 88. Divide that by 2, and we get 534.6 centimeters squared. For the last area problem, I do know this side. It's 16, so that means that my area is 16 times 1, 2, 3, 4, 5, 6. So my perimeter is equal to 96. I do need to figure out what this apothem is. So remember, this is a right triangle. So if the entire segment is 16, that means half of it would be 8. So that little section here would be 8. So now I need, sorry, put X in the wrong spot. This is kind of confusing. This piece here is telling us that this is 16. So I need to find my apothem, which is X. So I need to use the Pythagorean theorem. So 8 squared plus x squared is equal to 16 squared. And we get that x, our apothem, is equal to 13.86. So now I have everything that I need to find the area. So area is equal to 13.86 times 96. Divide that number by 2. And that is equal to 665.11 inches squared. Number 10, find the probability that a point randomly chosen on the figure is in the shaded region. So there's two shapes here for this figure. We have a circle and we have a triangle. So the first thing we need to do is figure out, okay, what is the area of the shaded figure? So let's first find the area of the circle. We know that the area of the circle is pi r squared. If you look closely, we notice that the radius is 5. So the radius, so we have pi times 5 squared, which is approximately 78.54. Next, I need to figure out what is the area of my triangle. Now, we don't know the height of our triangle. What we do know is that this part is 5, but I need to figure out what is my entire height here. Well, we have an equilateral triangle. So this here is 8, half of 8 is 4. So that means I need to figure out what is this entire length here, x, and to do so, I need to use the Pythagorean theorem. When I use the Pythagorean theorem, it would be x squared plus 4 squared is equal to 8 squared, meaning that x then would be the square root of 48. And I'm not going to show you step by step, that way you can save some time, but you can try that on your own and see if you also get the square root of 48. So now to find the area of this triangle, area is equal to 1/2 base times height. So 1/2 times the base we know is this entire segment here, which is 8. Our height is the square root of 48. And if you plug that into your calculator, you would then get 27.713. Now, if I want to figure out what is the area of the shaded section, I would just take my two areas and subtract them from each other. So when I subtract those two areas, I get approximately 50.79. All right, so now that I found the area of our shaded, we're trying to find the probability. So the probability is the part over the entire figure. So the part that we're looking at is the shaded part. So let's write probability. So that was 50.79. What is the entire figure? Well, that was the area of the circle. So 78.54. And if you plug this into your calculator, it is approximately 75%. So find the probability that a point randomly chosen on the figure would be in the shaded region. That would be 65%. And our last problem, number 11, find the probability that a point randomly chosen on the number line is in segment AC. All right, so once again, probability is part out of the whole. So the part is just segment AC, which is made up of 12 and 6. So add those up, we get 18. Divided by the entire segment, well, this is the entire segment. So 12 plus 6 plus 28, that is 46. When you plug this into your calculator, you get approximately 39%. So 39 is our probability.